All right, let's talk about your car. Not the engine or the horsepower, but the invisible security system protecting it, the AUTOSAR crypto stack. It's basically your car's digital bodyguard. And to get started, you need to know that your car has a lot more in common with your laptop than you might think.
Yeah, it's a pretty wild thought, but it's absolutely true. See, your car isn't just a bunch of metal and gears anymore. It's a really sophisticated computer network on wheels. And that means the very systems controlling your brakes and your steering are potentially just as vulnerable as your email. So they need some serious protection. So here's how we're going to break it down. First, we'll look at why your car is a target in the first place. Then, how the auto industry got together to build a standard defense. We're going to peek inside the crypto stack itself, see how it protects its most important secrets, and finally, wrap up with why all this tech stuff really matters for the future of driving. Okay, so to really get the risk here, you gotta understand what a modern car actually is. It is packed, and I mean packed, with dozens of tiny computers. They're called electronic control units, or ECUs, and these little guys manage everything, from your anti-lock brakes and engine performance to your GPS and your radio. And that's really where the problem starts. This huge, complex web of ECUs talking to each other is the heart of the issue. You know, every single one of those connections is like a potential digital door for an attacker to walk through. Without some kind of unified security plan, trying to defend this whole system would be a total nightmare. So, facing this huge challenge, all the big players, car makers, suppliers, tech companies, they realized they had to work together. They needed to create a common ground for car software, essentially building a digital fortress that everyone could use as a foundation. And what they came up with was AUTOSAR. Honestly, the easiest way to think about it is like a universal operating system for cars, kind of like Windows or Mac OS, but for your vehicle. By standardizing the whole software architecture, they could bake security right into the foundation, making sure every part, no matter who makes it, speaks the same secure language. Now, this is where it gets really interesting. The AUTOSAR specifications are written with incredible precision, almost like a legal contract. So when a security rule uses the word shall, that's not a suggestion. It is an absolute ironclad, non-negotiable command. This makes sure there's zero wiggle room when it comes to keeping the car and you safe. All right, let's get to the good stuff. We're going to pull back the curtain and look inside this digital fortress, the crypto stack itself. The best way to picture it is like a super secure corporation with a really clear chain of command for handling top secret information. So right at the top, you've got the Crypto Service Manager, or CSM. This is the public-facing office. Let's call it the department head. Anytime an application in the car needs something secure done, say encrypting a piece of data, it sends its request right here. The CSM grabs that request, figures out how important it is, and puts it in line. From there, the request goes down one level to the crypto interface, or CryIf. Now, this layer is basically a universal translator. Think of it as the super efficient executive assistant. It doesn't do the security work itself, but it takes the request from the CSM and makes sure that whatever hardware or software is doing the actual work can understand it perfectly. And that brings us to the bottom layer, the crypto driver. This is the specialist. This is the engineer in the secure lab who is actually doing the heavy lifting. It could be a dedicated piece of hardware, what's called a hardware security module, or it could be a pure software algorithm. This is where the real mathematical magic of cryptography happens. And what's really cool is that the stack is also smart about how it handles all this work. If a request is super urgent, like, say, verifying a command to the braking system, it'll work synchronously. It basically says, "I'll wait," and everything else pauses until it gets an answer. But for less critical jobs, it can work asynchronously. It says, "Hey, get back to me when you're done," which lets the car's computers keep doing other things. It's all about efficiency. So we've got the process down, we've seen the layers, but what about the actual secrets? In the world of cryptography, everything, and I mean everything, hinges on the keys. So managing those keys is maybe the most critical job in the entire system. And that job belongs to the key manager, or KM. If we're sticking with our corporation analogy, the key manager is the chief of security. Its one and only job is to protect the keys to the kingdom at all costs, from the moment a key is created to the moment it's destroyed.
And man, this thing is busy. The key manager does it all. It generates brand new keys, it securely updates old ones, it handles the delicate dance of negotiating shared secrets between all those different ECUs. It can even create new keys from a single master secret. And on top of all that, it's constantly verifying security certificates to make sure every part of the system is exactly who it claims to be. Okay, so we've torn apart the layers, we've met the security chief, but what does all this techie stuff actually mean for you, the person behind the wheel? And what does it mean for the next generation of cars? Let's tie it all together.
Here's the big takeaway, the most important thing to remember. This isn't just security that's bolted on later, like some app you install. No, this security is woven into the very fabric of the car's digital DNA. Because it's a standardized foundation, it means every car manufacturer is starting from the same trusted, secure blueprint.
So it all boils down to these 4 core modules working together in perfect harmony. You've got the CSM acting as the department head, the CryIf as the translator, the driver as the specialist doing the work, and the key manager as the ultimate security chief. This simple, clear, standardized chain of command is what makes the whole vehicle's defense so strong. At the end of the day, you can't think of security in a modern car as just a single lock on a single door. It's so much more than that. It's a complete chain of trust, designed and embedded right into the car's digital DNA from the very first line of code. Now, this framework gives us an incredibly powerful defense for the cars we drive today. But what about tomorrow? As cars get even more connected, talking to each other, talking to the cloud, and as we move toward fully autonomous driving, well, the complexity and the stakes are only going to get higher. So the question we're left with is, what does the next generation's digital bodyguard need to look like?